Alright class, section 6.5 covers the sum and difference formulas. Again, as always with every section of this chapter, I do highly recommend having your unit circle ready. So our objectives are to be able to use the sum and difference formulas to find exact values, use the sum and difference formulas to establish identities, kind of like we did in the last section, use the sum and difference formulas when we have inverse trigonometric functions, and solve trigonometric equations that are linear, so 1 degree in sine and cosine. No, why do these things always disappear? Okay, so cosine of alpha plus beta, where alpha and beta are angles, equals cosine alpha cosine beta minus sine alpha sine beta. So the sum and difference formulas for the cosine function, we keep the cosines together and the sines together. If I have cosine of alpha minus beta, that's going to equal cosine of alpha cosine of beta plus sine alpha sine beta. So these are our two sum and difference formulas for our cosine function. So let me copy them down real quick so we have them. So what if I want to find the exact value of 105 degrees? Well, 105 degrees isn't one of the angles labeled on our unit circle, but we could write 105 degrees as the sum of two angles that are in our unit circle. So we could write this as cosine of 60 degrees plus 45 degrees. Then I can use the sum formula for cosine. So I have cosine of 60 degrees plus 45 degrees is the cosine of 60 degrees times the cosine of 45 degrees minus the sine of 60 degrees sine of 45 degrees. That is when we go to our unit circle. So I have cosine of 60 degrees is 1/2. Cosine of the square root of 45 degrees is the square root of 2/2 minus the sine of 60 degrees, which is square root of 3/2, sine of 45 degrees, which is square root of 2/2. And I got all of these from our unit circle. So that gives me the square root of 2/4 minus the square root of 6/4. So I have the square root of 2 minus 6/4, or I could pull that apart, factor it as 1/4 times the square root of 2 minus the square root of 6. Now these are equivalent. Just be careful how MyMathLab wants you to enter in your correct answers. Let's work through another example. So I have to find the exact value of cosine of 5 pi over 12. So let me tell you the trick I did when I started working through all these problems. I went into my unit circle and I rewrote all radian angles with a denominator of 12. Okay, what does that look like? Well, that means, if I had pi over 4, I rewrote that as 3 pi over 12. If I had pi over 6, I rewrote that as 2 pi over 6. And I did that for every single one. Like if I had 7 pi over 6, I rewrote that as 14 pi over 12, right? So I just took every radian degree and rewrote it over 12, because then it makes it easier to see where two angles could add or subtract up to 5 pi over 12. Well, if I have the cosine of 5 pi over 12, that's the same as the cosine of 2 pi over 12, which is pi over 6, and 3 pi over 12, which is pi over 4. So now I have the cosine of pi over 6 plus pi over 4. And I can use my addition, the sum of a cosine formula to solve this. So I'm going to take cosine of pi over 6 cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 sine of pi over 4. Well, the cosine of pi over 6 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2, right? That's 45 degrees. Minus sine of pi over 6, that's 1/2. Sine of pi over 4, square root of 2 over 2. Again, all of this from the unit circle. And the reason we're doing this, and we aren't just substituting this into our calculator, right? Make sure it's set in radians, is because I want an exact value. And when you put this into your calculator, you get an approximated value. You get a value that's rounded, right? Just as like, if I want the exact value of pi, I'd write the symbol pi. But if I wanted to approximate pi, I'd write like 3.14152, right? I'm rounding. So when we want an exact value, you can't use your calculator. So I have the square root of 6 over 4 minus the square root of 2 over 4. So I get the square root of 6 minus the square root of 2 over 4, which is 1/4. Square root of 6 minus the square root of 2.